This is a brief introduction into a reading, Nutrient Deficiencies. And so this is not a PowerPoint, this is a document that is actually in your lab books. The only problem with the lab book is I don't have permission to share the photos. But in the document version, I do have all of the photos. And one photo that is not included is a healthy tomato leaf. So I have added that here in the module's content so you can see the happy, healthy, complete nutrition tomato leaf. If we go to the document, don't get overwhelmed with the number of things here. There's quite a few pages, but most of it is fairly straightforward. There is some important vocabulary, and it's in bold. Things like tip burn. And tip burn is something that I want you to be very careful when you're thinking of what that means, because here in lettuce growing country, tip burn can mean different things. So if I type into Google tip burn, and I look at certain images, and you can see where the tip of the leaf is necrotic or dying. And that is a type of marginal burn, actually, that is occurring on the tip of the leaf margin or the leaf edge. In lettuce, we have a specific type of condition which is associated with calcium transportation, and we call this tip burn. And because the term tip burn in a lot of different plants means a marginal necrosis of the tip of the leaf, it can be confusing that tip burn in lettuce is actually a calcium deficiency in certain cells. It doesn't mean it's a calcium deficiency in the soil, but maybe the plants are growing too fast and they can't transport calcium fast enough from the soil to the rapidly growing leaves, which occurs in warm weather. And you can see what happens in this photo. You can see the browning of the veins around the leaf margin, and that will eventually turn into a necrosis beyond the cells of the veins, and this entire leaf margin area will become necrotic when it gets far enough, and it will start to mold and secondary infection can come in. Tip burn is a very serious condition of lettuce that primarily occurs in warm weather or unusually warm conditions for any given variety. So tip burn is one right out of the gate that I want to point out. Most people think of tip burn as the marginal necrosis at the tip of the leaves, but in lettuce country, we think of tip burn as a lettuce condition associated with calcium transport problems in warm weather. So, chlorosis. Chlorosis, you already have seen that, a yellowing, you should know that term. Necrosis, you've seen that term, you should know that. The death of the cells that have either undergone an injury, a disease, or a nutritional deficiency or nutritional toxicity. So I want you to read this, pay special attention. Salinity. Salinity is the salt level in the soil moisture or the irrigation water. And it can be very, very stressful for plants to have excess salinity beyond their tolerance. Pathogens, we've talked about pathogens, organisms that can cause disease. We'll talk about them more later. But pathogens are things like viruses and bacteria, or even animals like the microscopic nematode worm, and air pollution. All of these things are conditions or situations that will cause stresses that will result in symptoms in plants' growth. Now, we talked about chlorosis, the yellowing of the leaves due to lack of chlorophyll. Why is there a lack of chlorophyll? Depends. There can be a number of things that cause chlorosis. Interveinal chlorosis means that the veins themselves stay green while the interveinal, or in between the vein tissue, starts to yellow. And that is something that is unique to certain kinds of either diseases, especially viral diseases, or possibly certain nutritional deficiencies. Something like zinc deficiency can cause an interveinal chlorosis symptom. Read through the environmental associations as well. There's some general concepts that I think are good to know. Don't worry about phytosideriphores. I'm not going to worry about that vocabulary word. That's why I unbolded it. Now, there's levels of deficiency. Acute means it's an emergency now, it's serious. Chronic is a more mild condition over time, but many chronic conditions can have extremely significant and severe long-term effects. And so you could think of something like an acute problem. You know, somebody is hospitalized because of pneumonia. That's an acute situation. It's major symptoms with an emergency going on right now. Chronic could be a chronic cough where you have some kind of a problem that is causing a relatively modest symptom at any given time, but it's over a long period of time. And chronic conditions can be very severe if they go on for long enough. For example, a chronic cough, depending on what's causing it, could end up down the road eventually becoming a life-threatening acute situation. And the same is true for plants. Chronic deficiency problems can result in severe symptoms down the road. Now you talk about micronutrients and macronutrients, micronutrients being those needed by the plants in small or trace amounts, macronutrients needed by the plants in large quantities. This talks about mobility. Plants can move the nutrients from one area of the plant to another. And when nutrients are taken up from the soil, they are moved in through the xylem, up the plant, or into the xylem and up the plant in a one-way direction from roots to shoots, out to the leaves. And so the initial distribution of nutrients is through the xylem. But when it's going to be remobilized or moved, a nutrient can't go down through the xylem. It doesn't work that way. Xylem is a one-way street. And so remobilization of nutrients occurs through the phloem. And so basically nutrients can hitchhike on the movement of sugars through the phloem. And So you get some redistribution or removement, relocalization, often from older leaves to the younger leaves. And I talk about the physiological tip burn here due to calcium. I've already mentioned that in this lecture, but I talk about it briefly there. Again, it has nothing to do with the calcium level in the soil in most cases. The vast majority of cases, there's plenty of calcium in the soil, just the lettuce is growing so fast that the plant can't keep up. It can't get enough calcium, which is a relatively modest speed process from the roots up into the leaves where it's needed. And so they run out of calcium at the work site, so to speak. Plant competition and induced deficiencies. So there are things where one plant might compete to grab nutrients and steal it from another plant, causing a deficiency in the loser. There are other conditions, induced deficiencies. For example, if I have a pH that is inappropriate, I can add lime to raise the pH, and all of a sudden I don't have enough iron in my soil. Or I can add too much calcium, and so the plants can't get enough magnesium. I've overdone the calcium where the plants just don't get enough magnesium, or just the opposite. Serpentine soils can result in competition where the high magnesium prevents calcium from coming in. So again, it doesn't necessarily mean that the nutrient is unavailable when a plant is experiencing a nutrient deficiency. The nutrient might be there, there just might be some reason to induce the deficiency so that the plant can't get it, or can't get it in high enough concentration. So please read that as well. Nutrient demand and use efficiency, I'll leave that to your reading. Diagnostic tools, I do want to point out a couple of things here. Microscopic studies of plant tissues, spectral analysis, meaning you're using the different wavelengths of light, and you're using specialized imaging techniques to look at plants either close up in a laboratory or from overhead in a drone photograph from overhead. And tissue analysis, where you take petioles or leaf tissue and send them to a laboratory, or soil analysis. All of these are ways of trying to diagnose what's going on. Now, there are a lot of people who can make diagnoses visually. Visual symptoms are part of the toolkit. You look and say, what's going on here? What does it look like? It's chlorotic. And if you see something that is chlorotic, why is it chlorotic? And in your own fields or own area, if you have lots of experience with those soils, those varieties of whatever you're growing, you might be able to make a diagnosis visually. But I would argue that the reality is very few people can make a good diagnosis visually without other information. So for example, if I see some chlorotic plants in my grape vineyard, and it's my vineyard, I know my soils, I know my vineyard, I might be able to say, oh, I'm running out of nitrogen, I got to give them a little bit more nitrogen. Or I might be able to say, oops, I got a problem, it's not getting enough iron. Iron can cause an iron-induced or an iron deficiency chlorosis as well. Can you clearly tell that from a few leaves, just looking? On somebody else's land? No, I don't think that's very realistic. You can make an educated guess and you might be right, but you need other information, because so many nutrient deficiencies and diseases and other stresses look very similar. And it's not a good idea to rely solely on what it looks like to the naked eye. So this section talks briefly about those tools. And then there's symptom descriptions. We've talked about some of the vocabulary, but you have to use the vocabulary appropriately. What is an internode, an internode length? What is the normal internode length? Is the chlorosis general, or is it splotchy, or is it intervenal? All of these things, being able to describe symptoms using the proper vocabulary makes it much more possible to communicate the symptoms among the people responsible for managing your crop plants, or the pest control advisor, or the crop advisor who is helping make decisions on what to do about the symptoms you're observing. And so the next set of slides is all about the actual symptoms, and I've made a few things bold, and those are the ones I want you to concentrate on. Magnesium shows an intervenal chlorosis developing into necrosis. There's a lot more details here, and this is just one example of what a magnesium deficiency might look like. You can see the intervenal chlorosis pattern in this very, very clearly. And don't worry about trying to memorize all the details here. Manganese, nothing stands out that's obvious. I didn't make anything bold. Just read it through, get a familiarity with what manganese deficiency might look like. Molybdenum, again, I didn't make anything bold for you to study. Some of these things can be very difficult to determine what's going on unless you've had that problem. You know it's a potential problem and you've seen it multiple times before in your own fields. Then you might go, looks like I got molybdenum problems. Nitrogen, this one you definitely need to know. Chlorosis or chlorotic, the adjective version. I have chlorotic leaves. That's the adjective describing what you're looking at. Chlorosis is the actual symptom itself. And with nitrogen deficiency, this is a really severe one. Doesn't get much worse than this. It doesn't have hardly any chlorophyll at all. The leaves are yellow. Usually you don't have something that severe, but nitrogen deficiency tends to be relatively general, where the entire leaf or most of the leaf looks pale and yellow. It's not completely uniform, but at least it's more uniform than the intervenal chlorosis of a magnesium or zinc, or the somewhat splotchy or uneven pattern with iron. So you need to know about chlorosis. You need to know nitrogen is a big deal with it. Phosphorus. In some plants, you can get a distinct purpling with stress. If they have the ability to make purple colors, things like grapes or tomatoes do have the ability to make purple colors in many of their varieties. And you don't see it here. You can't see the purpling on this particular photo, but if you have very severe phosphorus deficiency, you can see some purpling that occurs. Sulfur deficiency, there's another example of a chlorotic symptom, often often in the younger leaves, which is something that is unusual. Of all the chloroses, sulfur deficiency tends to be the most uniform, even to the older versus younger leaves. It tends to get the entire plant, where with other situations, even like nitrogen, the nitrogen will be mobilized to the young growth. So the young growth might not look very chlorotic in nitrogen deficiency unless it's really severe. And it's the older and medium-aged leaves that are turning chlorotic, and the young growing tips and the newly expanding leaves stay with their color but not necessarily so with sulfur. Zinc. Now, this can also have an intervenal chlorosis. This turned into necrosis. This does not show the intervenal chlorosis as much. This is really, really severe. And the leaf tissue is starting to die. Certainly the most dramatic intervenal chlorosis photo in this set is with the magnesium. Boron, this is probably the most difficult of all of the nutrients to hit the right level for many people in many crops, depending on your soil, depending on your crop that you're growing. It's very easy to have boron deficiencies, and depending on your soil and your irrigation water sources, it can be very, very easy to have excess or toxicities. For example, when I was in Davis, our tap water in Davis, where I lived, very high boron levels, and so it was not a problem for drinking, so I drank the water. It was perfectly clean, healthy, safe water for human consumption, but I noticed my houseplants were starting to get some marginal burn due to boron toxicity. Now, the photo here is boron deficiency, but in my case, in Davis, it was boron toxicity. So I ended up drinking tap water, and my plants were all drinking bottled water. But my house plants were gorgeous back then. Now, boron has a very narrow range for a lot of different crops between the level of what is considered deficient and what is considered toxic. So you want to hit that sufficient range in between those two extremes. Most nutrients, you've got a very big target, and with some crops, there's a wide range of boron issues. We don't think about boron as such a big problem for the vegetable crops in the rapidly growing leafy greens. Where we have the biggest problems are in the permanent crops, like our vineyards and orchards, trees and things that are permanent crops. That's where I hear people stressing about boron levels. And if you miss the boron level in something like a grape vineyard, you're not going to get good fruit set, you're not going to get seed development and ultimately berry development. You get these tiny little seedless sour fruits that are useless. You need enough boron, not too much. Very important nutrient. Calcium, also very important. Often it's not a situation where calcium is actually deficient, it's the translocation of calcium to the tissue. Most soils in the world have plenty of calcium. Some soils have too much calcium, not where it's going to be toxic, but it interferes with the uptake of other nutrients like magnesium because there's just so much calcium. So calcium is usually not a problem with the soil. Although we add calcium a lot, it's usually for some other reason. Many of the things that we add to the soil containing calcium are because we're adjusting the pH or we're making a change to the soil's tilth or structure. We're trying to make the soil, we're improving the soil. Calcium chloride. This one can be a real big, nasty problem, primarily because of the chloride levels getting into well water around here. In low rainfall areas, desert areas, chloride builds up in the soil, builds up in the groundwater as well. So chloride, I would say, is one of the biggest problems for well water in terms of our area and soil buildup in other areas. So here you can see some intervenal chlorosis, clearly high-stressed plants. They do not like too much chloride. Here you can see a leaf curling symptom of copper deficiency. That's a very common symptom. And once this continues for long enough, the leaves will turn chlorotic with little spots of necrosis. Very difficult to know for sure. There are diseases or even certain insect pests that will cause the similar leaf curling or leaf rolling appearance. Iron causes a chlorosis, and it's because iron is necessary in the manufacture of chlorophyll. And so even though even though nitrogen is the primary thing people think of with chlorosis, what's at the center of a chlorophyll molecule? Magnesium. So you need magnesium to make chlorophyll and have plants green. And what do you need to make the chlorophyll? In the manufacturing process, plants need iron. And so if you don't have enough iron, you can't manufacture the chlorophyll, even if you do have enough magnesium as a building block of chlorophyll, and nitrogen, also important component of chlorophyll. And you can see here the chlorosis is a little bit odd. It's an unusual pattern, and that's something that might indicate to a grower something might be going on with iron, because it is not a uniform color. It's not interveinal. It's not uniform on the leaf, as opposed to a difference between the young and old leaves. Well, that can be a lot of things, but a difference on the leaf like you see in this photo, a little bit unusual. And potassium. You get a lot of marginal necrosis, which also can be considered the tip burn that we're not talking about with lettuce, but that marginal burn or the tips of the leaves. In this case, it's this full margin burn on a lot of these. But if it's just at the end, the margin at the end, we would truly call that tip burn. Potassium is never incorporated into a structural component of plants. Plants need lots of potassium. It is a macronutrient, and it's always kept as K+ ions in the cytoplasm of the cells. And so it's for water balance, it's for activating enzymes, it's to make sure that the salt balance in the cytoplasm is appropriate. Very mobile nutrient in the plants. And here we have a generic chart, generic graph about the plant's growth or yield. How well does that plant grow to produce more plant or more of its crop, and the concentration of the nutrient along the bottom. So as the nutrient goes up from left to right, the nutrient concentration available to the plant, you start out with this weird thing called the Steenberg effect. I don't get into that here. We talk about that in plant nutrition class, but that's an unusual extreme situation. But usually you're in this deficient range, and it can become very severe, where the plant is damn near dead. And so you have this deficiency up to this critical range area where the plant is starting to have good production, good yield. And you have symptoms that can vary in severity and timing depending on how far down this deficiency curve you are. But you don't want to be growing your crops on this deficiency slope. And you don't even want to be right at the critical range. But you don't want to be too much above the critical range. The additional nutrients you need to add to move from critical range to the middle of the sufficient range is quite a bit. And how much do you actually gain in yield? Very little. So you probably, to go from critical range to the middle or upper end of sufficiency, you probably are spending more money on fertilizer to do that than you are getting back in yield. And it's also not good for your environment. The excess nutrients that you add end up potentially in soil and water, in the groundwater, in surface water. It can alter local populations of organisms living in the soil, living in the community, in the water, in your area. So you don't want to use too much. And this could be a graph that is representing any of the 17 essential nutrient elements, or 17 essential elements, the 14 nutrient elements in particular. We're not talking about CHO, the first three that are not nutrients, but the 14 that are nutrient elements. Any one of these would have a chart that would look similar to this, or a graph similar to this. Now, as a grower, since you really don't want to be too close to the critical range because your plants could easily drop off, you want to be aiming somewhere here where you're in the sufficient range, but you're in the lower end of the sufficient range. You're making the plants happy without getting too close to that transition critical range point. If I overdo it, I actually start to suffer in yield gradually until it becomes toxic and you have severe problems with your nutrients. And that's it for the reading, and hopefully that will help you understand as you read.